Okay, so in this video I'm going to have a look at hypothesis testing and p-values. In particular, I'm going to have a look at this particular example here, where we have a sports coach who's testing the effect of an energy drink on 150 athletes. Now, she knows that the mean time run for over 100 meters for athletes is 12 seconds. And this is for the athletes who are not taking the energy drink. Now, the mean time for 150 runners, for these 150 runners who did take the energy drink, is 11 seconds, and they have a standard deviation of 5 seconds. So if you don't take the energy drink, the mean time is 12 seconds, and when she tested the 150 runners with the energy drink, they had a mean time of 11 seconds with a standard deviation of 5 seconds. So it does look like there's a slight improvement, but is it significant? And we're going to have a look at it with a 5% level of significance. So let's just write down what we have first. Now we have a sample size. So we have n here. Our sample size is 150. We're looking at 150 athletes. We know that their average, or their mean here, their x bar, is 11 seconds. And we know that their standard deviation, the standard deviation of our sample, is 5 seconds. Now we know that the population mean is 12 seconds. And we don't have a standard deviation. We don't have a standard deviation for the entire population. However, we can use this one here. We can use 5 seconds here because it's such a large sample. It's well over 30. We have 150 athletes, and they have a standard deviation of 5 seconds. So we could use this one if we need to. Okay, so now normally what we do in this situation when we're asked to test the particular hypothesis is we would write down H0 and H1. So let's do that first of all. So we will look at H0, which is our null hypothesis. And the null hypothesis is, the status quo. What normally happens, what we normally think is correct here, and that is that the drink has no effect. So we're going to say the energy drink, the drink has no effect on the athletes. Okay, so in other words, the mean here will be 12 seconds. Our alternative hypothesis then is H1, and we'll say then that the drink has an effect on the athletes. On the athletes' times. In other words, that the mean is not going to be 12 seconds. So this is our null hypothesis and our alternative hypothesis. Now normally what we would do in this particular situation is work out our margin of error and see does the mean appear within that margin of error. So what we would do is, we would do this kind of thing here. Our margin of error is going to be equal to plus or minus 1.96 times our standard deviation over root n in this case. So this would be plus or minus 1.96. Now we don't have the population standard deviation in this case. However, we do have the sample standard deviation of 5 seconds. So we're going to use this as an estimate of a very good estimate, because we have 150 samples here, if you like. So we're going to use I'm going to use this 5 here. So that's multiplied by 5 over square root, and our sample here is 150. When you work that out, you get plus or minus 0.8002 rounded to 4 decimal places. Now normally what we would do then is we would say our population mean is going to be greater than or equal to our sample mean here, which is 11. Remember we we're looking here at 11 seconds. This is our sample mean. So it's going to be 11 seconds minus 0.8002, and it's going to be 11 seconds on this side plus 0.8002. So what we would end up here getting is that our population mean should be somewhere between 10.1998 and 11.8002. Now we know that our actual population mean here is 12 seconds, so which falls outside this range here. So we would reject the null hypothesis that the drink has no effect on the athletes. So that's what we would normally do. However, in this particular case, we were looking at testing. We're going to look for p-values or p-value, and we're going to test it to within 5% level of significance. So let's have a look at what we would do in this particular case. So let's just draw a line under this and start again. So what we're going to do here is we are going to assume H0 is true. We're going to assume that the null hypothesis is true, that the drink has no effect on the athlete's times. So what we want to do is find the probability then of getting a value of 11 seconds or a more extreme value than 11 seconds. So if the drink has no effect on the athletes, what's the probability of getting a value of 11 seconds or a more extreme value than 11 seconds? So let's see. First of all, what we have to do is find our Z value for 11 seconds and then look up on our Z table, which I have here, look up the probability. So let's have a look at that. Now, we're going to find the Z value. So we're going to look for Z values here. So our Z value here is going to be our mean, which is 11, a mean of our sample here, which is 11, minus our population mean, which is 12, then divide that by 5 over square root 150. This is the formula that we used in the past. This is x bar minus mu over sigma over root n. This was the formula we used to find our Z value for a sample distribution of sample means. So let's have a look at what this is. Now when you work this out here, you get a value of minus 2.45. So we got a value of minus 2.45. Now we want to find the probability of getting a value of minus 2.45 or more extreme than that. So in other words, say we were to draw a little sketch here. So we have our normal curve, our standard normal curve here, and we have our mean down along here. So this is 0. So you've got maybe -1, -2, -3, and we're looking at somewhere around here. So we're looking at values down along here. Now, because we're looking at has the drink had any effect on our athletes? So we want to know what is the probability of getting a value of 11 seconds, a mean of 11 seconds, or a more extreme value. So what we need to do is look at both sides of our normal curve. So we want to find the probability of appearing in this part of the curve, or indeed this part of the curve here. So let's just work it. We'll work out this part here and then we'll double it. So let's do that. So we want the probability first of all that our Z is less than or equal to minus 2.45. I'm going to multiply this probability by 2 to find the probability of appearing in this part of the graph or this part of the graph here. So this is just simply going to be equal to 1 minus the probability that Z is less than or equal to 2.45. We've done these kind of things previously in a previous video. So when you work that out, you get 1 minus 0.9929. So if you look up 2.45 here, there's 2.4, go out here as far as 5 here, and you get let's see, where are we here now? Minus 2.4 5. Let's see, there's 2.4 and there's 2.45 here, 9925. Let me just move that up here a little bit so that we can see where exactly they are. There's 0.05, so we go down along here to minus 2.45. So there's 2.4, so it's 0.99, so it's actually this value here, I think, isn't it? Yeah, let me see, there's 0.05, this is 2.4, 0.9929, actually, 0.9929. So let's have a look at that. 0.9929, I'll just wrote that bit out. So it's 0.9929. So when you do that, then, so it's 1 minus 0.9929. That gives me 0.0071. 0.0071. Okay, now I'm going to double this because we're looking at more extreme values than our z value of minus 2.45. So let's just multiply this by 2. So 2 times 0.0071, that will give me 0.0142, I think, isn't it? 2 and 2 stands for, we're going to forget 1. Yep. So just multiply that by 2. Okay. So in other words, the probability of appearing in this part of the graph, or this part of the graph here, is 1.42%. Now remember that we're looking at a 5% level of significance here, so we're looking at a 5% level of significance. So this is much less than 5%. So in other words, the probability of appearing in this part of the graph here and this part of the graph here is much less than 5% level of significance. So we would, in this case, reject our null hypothesis. There's a very, very low probability that we would get a result down here and up here as well. So it's much less than our 5% level of significance. If our percentage had been greater than 5%, then we would accept the null hypothesis that the energy drink had no effect on our athletes. But in this case, there's such a low probability of appearing here and here together that we would have to reject the null hypothesis. The drink is having an effect on our athletes. Now our p-value here is just a probability value, and our p-value in this case is just 0.0142. That's this value here. This is our probability value.